All right, in this section, we're going to be looking at using measures of center to answer some meaningful questions. And we're going to do some practice exercises similar to what you have on your homeworks and on the exam. So our first one is question number 14. It's on page 91 in your book. And we're answering two questions here with the sample data. So the data that we have is the ppm level of mercury in the sushi tuna. So the two questions we have is which store has the healthier tuna? And then the second question is, do these stores appear to be getting their tuna from the same supplier? So let's think about how we can get started on this and work our way through a question like this one step at a time. The first thing is looking at part one, the question, which store has the healthiest tuna? Now, to be able to answer this kind of question, the first thing you need to identify is what is the criteria being used to answer this question. So what criteria are we using in this particular problem to assess the healthiness of the tuna? Look into the problem for a moment, make sure you identify that for yourself, and then when you're ready, move on to the next slide so we can check. All right, what you're looking at here is the mercury ppm. So this is the particular criteria this problem has set for this question. Now, after that, you simply need to go and look at the data and determine which one has the lowest ppm of mercury. So take a moment and identify that. And that's in fact going to be Fairway. They have 0.10 ppm of mercury. That is the lowest of all of them. So that's how we use that to answer this particular question. Now, part two becomes a little bit more complex. So are they all using the same supplier? What evidence do we have for this? Well, in order to answer this question, we need to be looking at the kind of distribution we've got and whether we've got any outliers. So we need to calculate the measures of center for all the stores. So take a moment and go through and calculate that. Get that into your table, and then let's take a look at that together. So here we've got our mean, median. We don't have a mode in this data, and we have our mid-range. Notice that we've rounded to 1 decimal point beyond the measure, okay? So we've applied our rounding rules so that our data is all accurate. Now, let's make sure we work with this data. Notice that both the mean and the median are quite different than the mid-range, given that they are all from a range of 0.10 to 1.25. So when we're looking at this, we need to notice that this produces a particular shape of a distribution. Let's take a look at which shape of a distribution this produces. So here we have our mean, median, and our mid-range. Taking a few moments, pause the video here and identify how they would match on to each of these three possible shapes for our distribution. Which type of distribution are we looking at here with our tuna data? As you can see, our mean is actually lower than our median, and our mid-range, although not shown on these distributions, is even lower. So this suggests we're looking at a slightly left-skewed data set. All right, this would mean then, since we have a skewed distribution, this indicates the likelihood of outliers, which makes it unlikely that they're all getting their tuna from the same source. So this is our first practice problem solved. Let's move on and take a look at another problem. Here we've got problem number 22. And here we're looking at data, collection data from two different security companies. So one is Brink's Security Company, and the concern is that are they stealing? So we need to go through and look at our data to assess, do we have reasons to believe that these individuals, employees working for Brink's, are stealing when they're picking up the money from the parking meters? So let's take a look at how we're going to approach this particular question. The first thing is we need to decide what is the difference between the two conditions that would indicate stealing by the Brink's employees. All right, so we have two conditions. We have a Brink's collection rates, and we have the non-Brink's collection rates. So pause for a moment and think about this just in general language. If Brink's is in fact stealing, what would we expect to see between the two different data sets? We would expect to see lower collection amounts when Brink's employees are doing the collecting. So that's the expectation that we have. We've put it in general language. Now let's take a moment and look at what this looks like when we turn it into what I call statistical terms. So putting that basic language term into statistical terms, we would expect the measures of center for money collected when Brinks was the contractor to be lower than the measures of center of money collected when Brinks was not the contractor. Notice we've now taken this basic idea that we'd expect less money when Brinks is doing the collecting, and we've converted it into very specific terms, the measures of center, right, for the different money collected. So now we've taken our problem, we've put it in statistical terms, so the next thing we need to do is we need to go through and get our measures of center. Here we're going to work with just the mean and the median. So pause the video here, go through and calculate the mean and the median for both the Brinks collection condition and the non-Brinks collection condition. And when you're finished with that, turn the video back on, move to the next slide, and we'll look at the answers together. Okay, you should have got the information over here on the left. So Brinks has a mean of 1.55 million, a median of 1.55 million. Non-Brinks has a mean of 1.73 million and a median of 1.65 million. So, does this data show evidence of stealing by Brinks employees? What do you think? It does. Both the mean and the median amounts are lower with the Brinks employees doing the collection contracting. So, although this certainly would not be enough, obviously, simply to take to court on this alone, it would be good enough evidence to suggest that launching a more in-depth investigation would be a good investment of time and money. These are the kinds of things that we use statistics for. So, to give you another example of this from real life, at one point in time when I was applying for the National Guard, I'd gone pretty far in the recruitment process and then dropped out at the very end. My recruiter was being incredibly creepy, asking me to lunch all the time and wanting to take me up to a training site up in the mountains over the weekends, just me and him. When I told him I'd like to bring my father with me, basically because I was a little creeped out already, and my dad had served in the Coast Guard, so he was an officer in the Coast Guard, the guy's explanation was that that would be a security risk. I thought this was very bogus since I had not signed any contracts yet. However, an individual who had been an officer in the Navy was seen as being more of a confidentiality risk than me. So I dropped out, withdrew my application, and went and found another way to pay my way through school. Months later, I get a phone call from the officer that oversees all the recruiting for the state of Georgia, where I was living at that time, and he was calling to ask me what had happened with my recruiting process. So I was kind of interested as to why he was following up. They're pretty busy people. I mean, you can't check up on every one of these. And what he told me was that he runs regular statistics, not surprisingly, on his recruiters and looks for unique patterns. And he found the particular recruiter that I had contacted had a much higher rate of having female candidates advance so far through the recruitment process and then drop out. So his mean and median scores in these areas were very different. They were much higher in terms of dropping out than the other recruiters, and this had brought the situation to his attention, and so he now pulled the gentleman's file and was going through and checking them. So this is an example, again, when we're looking at some of these basic measures of center, individuals use them when you're working with very large data sets or overseeing large groups to be able to decide where you need to focus your attention. This is really important when you've got a lot of data that you've got to be covering. Basic looking at measures of center and differences between groups can highlight areas that you need to give your attention to, either because they're a problem or perhaps also because you're interested in exploring why they excel. Okay, now, our last part here is looking at the relationships between the mean, median, and mode. So let's take a look at these two data sets, and again, let's look and determine what kind of shape of distribution we're looking at here. So pause the video for a moment, and then go through and look at both the mean and median for Brinks and the mean and median for the non-Brinks, and tell me what shape of the distribution we're looking at here. The Brinks is in fact a normal distribution. In fact, honestly, having a mean and a median that match exactly is really kind of bizarre, and that alone probably would have gotten my attention to take a look at it a little bit more closely. That's just a little too exact for real life data. The non-Brinks data is a little bit right skewed, so we've got our mean is a little bit higher than our median.